All right, hello students. So this was the quadratics quiz we did recently. And the whole idea for skill number one, solving quadratics by reversing operations, is we're reversing the order of operations. And so this is that sad map that I've been talking about all year long. And the idea is that step one is going to be getting rid of any subtracting or adding that is outside of parentheses. Step two is getting rid of dividing or multiplying that's outside of parentheses. Step three is getting rid of an exponent, which in a quadratic means you're going to get rid of a squared. So you should be thinking of square root. And the last step is just dealing with whatever is inside the parentheses. So for question one, there's no subtracting or adding on the outside. There's no dividing or multiplying on the outside. So I jump right to the exponent. If you like, you can draw the square root symbol. The important thing is that you break it up into two pieces. X plus 3 equals 6. And the other square root of 36 is negative 6. So you have x plus 3 equals 6, x plus 3 equals negative 6. After you do exponent, that's the e, the last thing is p for parentheses. And what that means is whatever was inside the parentheses. When I take the square root, I don't have the parentheses anymore, but I have the plus 3. X plus 3 was what was inside the parentheses. And so the opposite of plus is minus. So I go minus 3 minus 3. And I get my two answers, x equals 3 and x equals negative 9. If you check your answers, you would just put those numbers back in for x in the original question. So checking, does 3 plus 3 squared make 36? Yep, 3 plus 3 is 6. And then does negative 9 plus 3 squared equal 36? Yep, negative 9 plus 3 is negative 6. And two negatives will make a positive when you multiply them. Moving on to number two. This one we have a little more action to do. First is S or A for subtracting or adding. So we cancel out a plus 64 by doing a minus 64. 0 minus 64 is just negative 64. Then we dm, divide or multiply. Divide by negative 16, giving us x minus 3 squared equals 4. Then we e for exponent. Square root of that gives us the two square roots of 4, positive 2 and negative 2. And then last is p for parentheses, and what was inside the parentheses was x minus 3. So we get our two answers of x equals 1 and x equals 5. Checking your answer, and you can of course use a calculator to check your answer, but you should at least show me the setup where you're replacing the letter x with each of your solutions. This one works because 5 minus 3 is 2, square that is 4, times negative 16 is negative 64, plus 64 equals 0. You can also just type it into your calculator, like I said. Also check your other solution of x equals 1, and you'll see that you get the same. Oops, I wrote a 2 instead of 3. You see you get the same result. 1 minus 3 is negative 2. Square that, you get 4. The rest of it is the same. So those are the solving problems. Now sliding on down to skill number 2, graphing quadratics by making a table and identifying characteristics. You do not need to do the shortcut method. We can just make a table. The thing that's nice about making a table is always thinking about what number makes x minus 1 equal 0. So if x minus 1 equals 0, that tells you that x equals 1 would be your vertex. So I'm going to make a table with 1 in the center of the table. I'm going to count backwards by 2 steps and count forwards by 2 steps. And I'm just going to plug in each of those and go through it. So just follow as I plug it in. Negative 1 minus 1 is negative 2. Square that. 4 minus 4, 0. Then I go x equals 0. 0 minus 1, negative 1. Square that. Positive 1 minus 4, negative 3. Next up, 1. 1 minus 1 is 0. That's why we called it the vertex. 1 minus 1 is 0. Square that. 0. Subtract 4 is negative 4. Next up, x equals 2. 2 minus 1, 1. Square that. 1 minus 4 is negative 3. Last one, you should be able to predict it. Think about it. Should end up being 0 because of symmetry. 3 minus 1, 2 squared, 4 minus 4, 0. That's good enough to draw the graph. Negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0. Identifying your features. The vertex is 1, comma, negative 3. Your y-intercept is, 1, comma, negative 4 for the vertex. Your y-intercept is 0, comma, negative 3. And you have two x-intercepts right there. The x-intercepts are negative 1, comma, 0, and looks like 3, comma, 0. So there you go for skill number 2. Moving on down. Skill number 3, comparing linear, exponential, and quadratic. Table number 1 goes down by 6, and then it goes down by 4. So I know it's not linear. And then it goes down by a fraction. And if it went minus 6 and minus 4, if it was quadratic, the next number would be minus 2. But it doesn't go minus 2, it goes to a fraction. So I know that there's an exponential pattern. I know it's exponential because it's not a constant or linear change. And I can find what the m is by dividing any two consecutive y values. If I do 12 divided by 18, I will get 2/3. If I double check that and do 8 divided by 12, I also get 2/3. So I know the equation for it is y equals 18 times 2/3 raised to the x power. And I know that to get the next values, I just multiply by 2/3. So 16 times 2, 3 times 3, 32 times 2, and 9 times 3. Believe it or not, those numbers are getting smaller. Number 2, I see that we're going minus 6, minus 4, minus 2. I know it's quadratic because the change is linear. The next change is going to be minus 0. So that's going to stay at 6. And then the next change is going to be plus 2. So it's going to go back up to 8. And the last one is linear because the change is constant. Each time it goes by minus 6. And so that's how you identify the type of pattern that we're looking at. Now we have the quadratic visual patterns. The way that I see this is that there is a square in the middle, and then there are two rectangles attached to it. And the size of the square matches with the S number. This is a 2 square. This is a 3 square. This is a 1 square. And the size of the rectangles also matches with the S number. 2 and 2, 3 and 3, 1 and 1. So if I wanted to draw S equals 4, I would draw a rectangle that's 4 units wide. I would draw a square that's 4 squared. And I draw another rectangle that's 4 units wide. Remember that I don't need you to draw each and every box. I don't need you to worry about the boxes looking like they're the same size. I just need you to show me how you can visualize the way that the pattern is growing. So the number of tiles in pattern 10 then is going to be 10 plus 10 squared plus another 10. And that's me going basically from top left down to bottom right in that order. So I guess that's 120. And in general, the number of tiles, ooh, that's a weird looking Y. The number of tiles is S plus S squared plus S, or if you want to simplify, S squared plus 2S. And that's it. So please comment, ask questions if there's something that was confusing. This is a check-in for how you're supposed to be doing in the unit so far. And if anything is missing or is confusing, let's try to fix that. So think about Flex or think about asking for help or what other videos I can make to help you get there. Thanks.